So my name is Aaron Blake. I am one of the CAM application engineers for Applied CAX, and so today I'm going to start off by kind of just real briefly going over a few things that we've noticed, kind of consistent issues that we've seen at customers when we go over there, and we kind of they want us to take a look at what kind of improvements they can make to help boost efficiency. And so the two main ones is reuse libraries and feature-based machining. So I'm going to go over a few quick examples of both, and then we're going to get into what's new in NX 1202. So, like I said, one of the biggest things that you can use is the reuse library. Pretty much anything that you use more than once, whether it be fasteners or base plates, tombstones, pretty much anything can be turned into a reuse library. And reuse libraries can be, simple, just dumb models with no knowledge built into whatsoever, or you can have complete assemblies with knowledge built in, which kind of essentially turns it into have kinematics in there. And so there's four main parts. There's the main panel, which essentially is the file structure of your reuse library. Search panel. If you have large files or a lot of components inside a particular file, you can search for whatever you're looking for. And then you have your selection panel, which allows you to add filters or search for components or assemblies or knowledge components. And then you have the preview panel, which, like it says, shows a preview. And so I'm going to show you just how quick you can set this up. So first of all, the reuse library is on your resource bar, and so it's the three little books on the side. And so when you click on it, usually it just looks like this, and so you don't see any of the other windows. You just go right down here and just single click, and you'll see all the other windows there. So that's one thing that a lot of people miss is they don't think that there's an extra window down there, but there is. And so if you want to add an initial reuse library folder, all you do is just right click and then in the open spot and hit library management. And so inside there, you can just click on the books again, and you just navigate to wherever you want, wherever your files are stored. Just go there. You can name it whatever you want, and it just pops up right there. And so you can navigate down through it. You can expand it down, and it's just going to go through all the folders inside that parent folder and just show you all the different parts. And if you can set the display to show previews of it. You can show a list. So kind of like your componentry. Another main part of it is if you have fixtures, if you're constantly making fixtures or use hardware such as cap screws or something like that, you can build knowledge into it. And so I'll show you a quick example of that. So right here is your filter. And so KE parts are knowledge enabled. And so what this means is that there's certain parameters built into this part where you can just drag it in and it pops up. And so cap screws you can have, quarter 20, half 13, 3/8, whatever you want. And so you can just select the size and length that you want. And this is all completely customizable. So if you want to jump between metric and standard, if you want to jump between, typically if you have cap screws or button heads or something like that, you'll do different models, but you could theoretically build it all into the parameters. And so you can add multiples in there if you want. And then so if you have multiples, this scatter option will determine whether or not it just lays them on top of each other, or if you hit scatter, it will just scatter them throughout the part. Once you do this, you can just treat them right, just as a regular component, and so you can unpack them, and you can move them wherever you want in the assembly. Another option you can do is you can have vices, and so you can see this brought in a vice component, and so I can just set it to whatever vice opening I want.
You do that via a reference set?
So this is a knowledge-enabled component, and so if you go into the reuse library and you have knowledge built into it, it's got a Excel file and a KRX file, and so it uses both of those. So this is just a very basic, it's a very basic example, and so it just has all your different variables in here. And so, and if you want more information on this, we can, you can contact me or Elizabeth or someone or Taylor, and we can kind of help you guys develop this kind of assemblies.
Configuration.
Sort of, yeah. And so it's there's a couple different ways you can do it, but the main way is you create a model, and then you attach a bunch of different expressions of parameters inside that, and then they use this combined with the KRX file, which is right there. And so you can determine what parameters you want it to show up. But like many times, if you have a vice and you bring it in, you don't always know exactly what size you want it to bring in as. But because it's got knowledge, you can just right-click and edit reusable component, and you can change the different parameters to whatever you want. And so you can treat it just as a component. There are ways where you can bring this in, and instead of a component, it's in your object, in your part navigator. It just kind of depends on what you're looking for. And so that's one thing that we see a lot of people not utilizing. And so if you're using something multiple times, rather than having to go in and search for it and find it every time, it may not take long. If you have shortcuts and whatnot, you can find it, 30 seconds. But, you do 30 seconds over and over and over again over the course of your career, that's going to add up. And so the reuse library, it's a real quick way. You can search, you can find things, and it's, you can manage it locally. You can set it up on a server so everyone has it. If you use custom environments, you can have it just automatically there when people open it up. You can even, so if you right click, you can even tell it what applications to put it into. So it is application specific. So if you don't want to see a bunch of capacitors inside of your drafting reuse library, you can not have that selected. It's all just a matter of whatever you want to do. And so it's incredibly customizable to whatever your needs are. But for whatever reason, it's just something that typically a lot of people don't utilize. And so there's a lot of power behind it. It does take a little bit of setting up, but that's something that we can be a resource for. Does anyone have any questions about the reuse library? All right, and the next part is feature-based machining. And so Siemens has been putting a lot of effort into feature-based lately. And so you're seeing the out-of-the-box processes, really improving just out of the box. But with feature-based, you can teach it how to identify features. And so if you have a particular feature that you want to cut the same way every time, you can teach it. Right now, it's a little bit tricky. You have to go through the machine knowledge editor. Typically, that's a job for a NX admin that requires, or you outsource it through a contractor. They are improving that to where you won't need the machine knowledge editor, but it's not quite there yet. You'll see it soon, probably. I'm guessing in the next couple releases. But it's something that it's another thing that's very powerful if you want to utilize it. But even just out of the box examples aren't. They're a really good starting point. You can get really far with minimal clicks. Another really good case for it is that you don't have to create tools. It will identify the features and it will automatically bring in all the cutting tools that you need. So I got a quick example of that. All right, and so you can even use the use library as a folder to open up parts. And so you just saw, I just opened it up, right click, open. And so we have this part here, and all I've done is identify an MCS part, and then just the blank is just part outline. And that's all I've done so far. There's no programs, there's no tools. And so what you do is you go down to Machining Feature Navigator, and you just right-click, Find Features. And so out of the box, you typically use panoramic recognition. This can be very customizable. It takes a little bit of time, but right out of the box, you typically use panoramic recognition. Geometry, you can select whatever you want. You can select workpiece. If you have a bunch of components, you probably don't want to machine the components, so you would stay away from all geometry. But for this example, we're going to do workpiece. And here's where you can identify what to recognize. And so if all you wanted to do is recognize a particular feature type, you would just have that selected. You can just leave everything selected if you'd like, but it's going to go through each one of those selections and evaluate on your part if there's any of those features on there. So in order to save time, it might be best to select what you're particularly looking for. If you're not sure, you can just, if you're not sure if it's going to work, just select it. One thing I will mention that if you're trying to drill holes or hole mill holes, those are steps. Holes are not holes. Holes, and inside feature recognition, the holes specification are non-circular through objects. So if it's circular, as a counterbore hole, countersunk hole, threaded hole, those are all steps. So that's one thing that some people get confused on a little bit, but once again, holes are non-circular. If it goes all the way through the part and it's not round, that's a hole. Otherwise, it's a step. And so if we had a bunch of features or a bunch of different surfaces right here, we can identify specific faces to search. But for this example, we're just going to keep it as the tool axis. And then you can limit the search area also. And so all I really did was select the search area and find features. And so you're going to see that it automatically found, all the features that I found are lit up in red. And so you just hit OK. And here it's everything that I found. And at this point, we can group all the features if we wanted to, and it's going to group them into geometry groups. So you can do that right there. But that's not going to create any operations. It's not going to create any tools. So we're going to create feature process. And so just like in feature recognition, it gives us an option of what kind of operations we want to look for. And so you can keep them all selected if you want. If you want to cut down on some processing time, you can just select what you're particularly looking for. And we're going to put all the geometry groups inside the workpiece. You can set it automatic if you want. You have a bunch of different options right here, depending on what you're looking for. But for this example, we're just going to put workpiece. And then you just hit OK. All right, and so now you'll see that some of the step holes with multiple operations have spot, drill, center. And so now if you go into your geometry view, you're going to see that it created all of these different geometry groups just automatically. If you go to your machine tool library, or your machine tool view, you're going to see it brought in all these different tools. And then if you go to your program, you're going to see that it created all the tools, all the programs for you. And so at this point, all you would have to do is just generate. And if you customized it a little bit, you can set all your initial engages, all your initial step downs, speeds, everything. But even out of the box, it's, in the amount of time it took me to do this, I couldn't have created all these operations. One thing you might notice is that it split up all the different spot drilling operations. And so if you look at them all, that's not necessarily the most efficient tool path. But once again, and I just figured out a way around that. So you just right click on the program parent group, go to object, optimize. And so it's going to look at all the operations inside this folder, and it's going to try to condense what it can. And so it's pretty quick for spot drilling. And so now you're going to notice, I just generate it. And so now it went in and identified all the different holes and created a optimized pattern for it. At this point, all these below operations are kind of just there. You don't have to generate them when you post them out, because when you post, it's just going to go straight to the optimized. It's going to run the optimized program, and then it's going to jump down to the next one. If you do generate it, it's not going to affect anything. You can even just object approve it. It's up to you. You can leave them ungenerated. You can still post it as long as the optimized is generated. And so that's just kind of a brief feature base. Like I said, right now to teach features and to teach processes, it's a little bit cumbersome. Just with, you need a lot of knowledge about machine knowledge editor. But that is going to be resolved shortly. Does anyone have any questions about this? So just kind of recap, I mean, it's a really quick tool to get a lot of stuff done quickly. Out of the box, you might need to refine it a little bit, but like I said, it'd be very challenging to program all of this in the amount of time that it took me to just do feature-based. Yeah.
Is there any documentation on the machining knowledge editor?
If you go to the PLM forms, there is a little bit in there. Also, there's quite a few tech tip videos on YouTube from Siemens. I believe it's on PLM World as well. So there is some knowledge out there. What's that? Okay. Yeah. So it's a little sporadic out there, but there is knowledge out there, and it's not something that we recommend, everyone doing. It's typically something that you want like one NX admin to kind of do and maintain. That way, everyone's kind of on the same page, because you don't want someone going in and changing an engage or changing a step down, and then no one else, it's going to screw somebody else up. And so be a little bit careful about that. But yeah, there is some knowledge out there. And so now we're just going to jump into what's new with NX 1202. There's a lot of CAM stuff that's in there, so I'm just kind of going to cover some of the highlights, some of the things that I've had a lot of customers kind of bring up or ask about. They've done a lot of stuff with surfacing and kind of minimizing engages and minimizing unneeded moves. And so the first one is area milling. They've included a helical cut pattern for steep regions. And so this allows the cutter to just do one continuous kind of helical down the part. Whereas in the past, the best option was usually Z-level ramp-on shape, where it would do one round around the part at one level and then transfer down. Not too bad, but not exactly the most efficient. Whereas now you can just start and you can just ramp on down the part, and so it's a nice continuous cut pattern that really can improve tool life and increase or decrease runtime. So similarly, so that was for steep geometry. They also added some spiral cut pattern for non-steep geometry. And so, likewise before, it would just do concentric circles around, or concentric profiles around the part, slowly working its way in or out depending on what you selected. And then it would just do a transfer move that, much like the Z level, not terrible, but it could leave a weird mark on your surface if depending on how you were cutting it. And you can use both of them together to just do one continuous spiral all the way to the center. And it takes very little manipulation. You don't have to do a lot of clicking. You essentially just click click the walls, click the floor, and it just figures it out. One thing to note is for helical, if you the first time around the profile, if it's doing in a helical on a steep, it could potentially be a lot heavier at the end of that perimeter on that first pass. And so they added finish passes, and so you can put a finish pass on the top or on the outer shape. And so in this case, it would be on the top and then on the inner. This is the inner shape really helps for for geometry that doesn't go directly to the center. It can help depending on your cut, your step over, and your cutter. But all it does is it adds a final pass. Kind of like with hole milling, you can add finish pass, and it does one complete revolution around the circumference, across the circumference before going down the next level. So this is pretty much the same idea behind that. Another method, and so that's very good for symmetric geometry, or if you have a lot of the same geometry, a lot of symmetric pockets in a part, you can do them all in one operation. I have a little example about that. So you can see that this is using area mill spiral with both the spiral and the Z level. Or it's just zigzag. But so this is showing the spiral non-steep. And so in one operation, it cuts every one of these cut areas in a very clean cut pattern. So it starts off at the outer part and just works its way in, slowly concentrically stepping over. There's no, you don't see those green step over lines that you used to see. It's just one continuous motion per geometry. But if your geometry isn't very symmetric, they came out with guiding curves, which is, I like to think of it as the next level streamline, without having to deal with all the projection vectors and everything like that. It automatically figures all that for you. So variable axis guide curves came out in 1201, and fixed axis guide curves came out in 1202. They're both pretty much the same, with the obvious exception that variable axis can have a variable tool axis, whereas fixed axis doesn't. They're both very powerful. You can create very complex surfacing operations very quickly. Inside both of these, the cut patterns that you have options of are morphing, cut, constant offset, and racetrack. And so I'm going to go over all those a little bit. And so constant offset uses a single guide curve. It can be an open guide curve. It can be a closed guide curve. in this example, if I did select the entire perimeter of this part, it would have just done essentially like a concentric circle or concentric pattern all the way around till the center. It's a little hard to see the constant step over in that though. So this is just a single open guide curve, and you can see over here that it's it starts with the parallel to the original guide curve, and it just constantly steps over. When it finishes, it's going still parallel, or at least as parallel as it can. One area that guide curves really shines is on surfaces that aren't flat. So as you can see on this part has a lot of kind of flow to it. And whereas if you did streamline, if it was a real complex, flow on it, you might have to deal with the projection vectors a little bit. And so sometimes that can be a little bit tricky, but guide curves automatically just lays the toolpath on top of it, and you're just good to go. And so morphing uses two guide curves. Once again, it can be open or closed guide curves. I'll show you an example of closed guide curves here shortly. But it's essentially it's telling it to the start and end cut directions essentially. And so on this example, you can see that it starts going the same direction as the first drive geometry, but at the end, it slowly morphs its way to going parallel to the second drive geometry. And so both of these operations are very quick to do. Very, very few clicks are needed for this to get a very good toolpath right off the bat. If it's a very complex surface, just be a little bit warned that it's crunching a lot of numbers in the background. And so this part isn't bad at all. It's about the same as area mill, but if you have a really complex one, it will do it very well, but it's just going to take a little bit of time to generate. So just be a little bit aware of that. And so our third option is racetrack. So racetrack is essentially you just pick one open guide curve. It has to be open, and then it starts there, and it just slowly does circles around until it gets you can either select how many times you want it to, how many racetracks essentially you want it to go around the part, doing a helical step over, or you can just tell it to do, on this example I did 50,000 step overs until it hits the end. And so, it's going to go to the end, and it's going to step over, and it's going to go to the next spot. And so,
is there any way to relate material to inches per minute or standard machining practices?
I'm sorry?
Is there any way to relate standard machining practices to material you're cutting here?
Like,
is there any kind of guidelines for that?
Using particular speeds of feeds for a particular metal?
Yeah, exactly. If you're steel versus aluminum, or is there any kind of database?
There's a couple ways you can do that. So that's a little bit off of what this is, but you can use the what is it called? I'm blanking on. There's a particular library in there where you can set all that up. And so if you'd like, you can talk to me after the class, and I can get you some information on that. So you can set up specific speeds of feeds and operation defaults based on material and cutters. It takes a little, like every library, it takes a little bit to set up, but once you have it established, it's very streamlined. So as I mentioned earlier, guide curves, especially the constant offset and the morph, they can be open or closed guide curves, and they can be arbitrary. You don't have to select, curves that are on the surface. You can select curves, that are, on a flat surface above above the part. These ones just happen to be projected onto the surface, but NX will figure it out either way. If you did pick a closed guide curve for your constant offset, which can only use one guide curve, it will start there, and you can go in to the interior of the part, or you can go to the exterior of the part, or you can tell both. And so, your guide curve, if you want to machine this entire part and you want to start at the center of this circle, you could tell it to do both, and it's going to do the entire part. And so you have a lot of power with these guide curves. I could go over this for probably an entire day of all the different things you can do with it. And so this is very brief. So if you're interested, contact me after the event, and I can really go into this a little bit more. But so constant offset, you can select one, and it does, either everything on the inside of that closed guide curve, everything on the outside, or everything in between. The morphing option, which uses two guide curves, you can select an inner and outer boundary. And so, if you have like some rework area that you want to do and you want to avoid a particular area, you can draw guide curves around that until it's just to machine that one particular area. If you have a part with, a contact surface that requires an extra fine finish, and you don't want to run that fine finish on the entire part, it's a very good tool to just quickly, run a custom toolpath on that area. And then, as I mentioned before, racetrack, you can tell it how many times to go around the guide curve. And these are all associative. So if you change your guide curve geometry, it will, once you regenerate the operation, it will conform to the new guide curve. And then, so that's all. I mean, that's fixed and variable. Both those work for both of those. One nice thing about variable guide curves, which I used often before fixed guide curves came out in 1202, is you can essentially fix the guide curve on variable guide curve, which is kind of confusing, but you can lock it in a particular orientation. One really nice thing about that also is you can set an avoidance axis smoothing and set it to tilt and retract. And so what that will do is it will fix that guide curve everywhere it can, except for where there's going to notice a collision. And if it sees a collision, it's this avoidance and axis smoothing allows it to tilt away to avoid that collision, but still try to get as much, surfacing as it can. And so there's a little quick video on this one. And so it starts off fixed, but as it gets closer to that wall, it starts to slowly tilt. And so it's a very quick tool to, if you want to get underneath that overhang, but you don't want to have, a bunch of weird tilts in there, or, it would be a little bit tricky to, create an ideal axis for this particular geometry that would work perfect. But you can fix it, and you can just tell it to just tilt when needed.
So you can control what axis it throws on?
You can. And so, like the fixed axis right here is just, I set it to ZM, but I can set it to whatever I want. And you can even set it to like a relative. Let's see here. So with this, you can set your tool axis just like all the other variable contour operations. You can set normal to drive, relative to drive, away from a curve. You have all of the options that you had in most of the typical 5-axis operations, but you have the added ability to fix it, and so it's stuck.
Do you have that in the avoidance as well?
In the avoidance?
So if you want to stay fixed in an axis, then in the avoidance, you only want to tilt in a certain axis.
Yes. So that goes down inside this axis smoothing, and so inside here you can tell it, what you want it to tilt. And you can get pretty deep into there, and then you can also go into like your avoidance area. You can just there it goes. So depending on what you want to do, you can set different regions to, you don't typically use this too much, but you have a lot of power in here to tell it what to avoid. One thing I've also done is, you can set this particular face as a check geometry. And then if you want to stay away from that a particular amount, then you just add that to your check geometry. And so, yeah, so you can manipulate how much it tilts and whatnot, and where it tilts inside there. And one thing I've noticed with the variable axis, they're still improving on it. 1201, it had all these capabilities, but I did notice that some of the algorithms, it wasn't always perfect, or there was a few areas where it may not have been exactly what I wanted to machine. But with 1202, I went back with the same exact part, and the algorithm was improved enough to where it performed a better toolpath than I expected on 1201. And so, I'd go through and change this a little bit more, but like I said, especially when you're trying to do tilt, it takes a little bit of operation, or a little bit more to generate the toolpath, and so because it's running through a lot of calculations in that background. This one's not super bad, but if you get to a really complex surface, it can slow it down a bit, unless you have a really fast computer. And so, one thing they also did with both the area milling and the guide curve drive methods is they added a path smoothing, and so. You don't really see it on this part, but when it makes a vector change, if it's going one direction, it's got to change. A lot of times, NX, you'll notice for surfacing, we'll just do a right angle move. And so, if you're surfacing, you're trying to get a really nice surface finish, that could cause a little bit of a mark. And so, Siemens has now put in path smoothing inside both area milling and guiding curves. They are only available for these particular cut patterns, but right now, at least when I checked in 1202 maintenance pack 2, for the fixed axis, this was the only options in there. I believe multi-axis has a little bit more options, but right down here is where the path smoothing option is, and so if it's available, it will show up. If it's not available, it won't be there. It's just it comes and goes depending on if you have these particular cut geometries or cut patterns are identified. And so this isn't a great example. The next slide's a little bit better, but you'll see this is the area milling, and so you'll see on this one it's really 90-degree transitions, and on this one it just adds a little bit of radius on there, which really improves surface finish, and depending on your machine, could increase cut time because it doesn't have to stop and then change direction. So here's a little bit closer view. So this is on a guide curve, and so on a transition, on a direction transition, without it on it, it's just a sharp corner. But with it off or with it on, it's just a round transition. It's a little thing, but it really can improve surface finishes. Yeah.
Would that also improve sawtoothing that it will have to do with the slope of the steam?
Sawtooth? Are you talking about that little jagged?
Yeah.
It does a little bit. If it's a really bad jog, it won't do that completely. One thing I would recommend for that is if you're using a toolpath that has the option inside non-cutting moves, you have the smoothing option, and so playing around with these a little bit can help that. Another option would be adjusting your in-tall, out-tall. There's little things in there if the sawtooth is pretty jagged. That's one thing that I get a lot of customers asking me for support on is, and it really depends on what's causing that. If it's just a really complex tool path, if it's just a bad surface, all those require different fixes. But one thing I have noticed is that the guide curves, especially, really limits that sawtoothing action. You really don't see it to the extent that you're used to. Like I said, I've only seen it on really bad imported surfaces. It was just horrible. It translated over really poorly, and that's the only time I really saw sawtoothing with guide curves. And so that's all with the guide curves and area milling. Does anyone have any additional questions on those? All right. So one thing that came out in 12 is adaptive milling. And so I believe in 1201, could have been a preview, but they came out with pillar cutting. And so if you're cutting a surface to the center, it will, a lot of times, if you're doing a really deep depth of cut, it would leave that little pillar on the inside, and either you just live with it and just, potentially damage the tool, or damage the part, or you had to create special geometry, cut avoidance, trim boundaries, whatever. But now you can turn on minimum or pillar cutting to cut helical motion, and NX will automatically identify that and cut that pillar down with a helical toolpath, much like kind of like a hole milling operation. So here's a little quick video on that. And so here's standard, the old way that NX would look at it. So right there, so also, if it's not completely circular, you get the same issue. See, it automatically identifies pillars and accounts for them. So now it's just going to come up and just going to heel it all the way down. So that eliminates that little pillar in there now, and it just automatically solves it for you. And then if it's not a round geometry, it will cut it into a round geometry and do a similar helical motion down. And so that's a new improvement that can improve and decrease programming time. Another option another new thing they put in there is, especially with the adaptive milling, your engagement helical engagement is the only option that you have with adaptive milling at the moment for closed areas. And one thing that you might have noticed is that you may not want the spindle and the speed and feed to be the exact same, for your engagement. Whether your tool, depending on your tool, you might want to slow down that feed rate a bit because it's pretty big depth of cut. And so now you could tweak it a little bit inside custom feed rates, inside the feeds and speeds options, but now it's automatically right there in the engage for adaptive milling. And so it's really quick. You can just change it to whatever you need. You can even add a dwell, so when it gets down to the bottom, especially I've noticed with certain machines, when it's getting down there, especially if you have your speed and feed, drastically reduced, sometimes your feeds, can ramp up to speed faster than your spindle, and so this dwell allows your spindle to kind of catch up a bit in order to before it just starts feeding into the part. And so another improvement that they did in 1202 is they've added minimum curvature radius for adaptive milling inside corners. And so before it would just get as close to the corner as it can, which would result in a lot of really tight small cuts. Which if you're trying to get as much out, or if you're trying to remove as much material as you can as fast as you can really slow down the toolpath. And so now it allows you to increase that radius, which would, it will leave a little bit more material, but you can come in there with a more refined toolpath and clean that out. And so this allows you to maintain that fast, efficient toolpath with adaptive milling. And so your feeds or your minimum curve radius has to be between 5% and 20%. And so, or 5% and 50%. And so that 5% is just set as a minimum, just so that, anything lower than that it's not really going to be effective. And so they set that 5% in there, and then 50% is the max. So it allows you to, reduce these little tiny moves inside there, depending on what your cutter parameters are. So that's about it. Does anyone have any questions about the adaptive milling or anything else that I covered? All right. Well, thank you very much.
Thanks.